Can you adjust it to that's pointing the whole board? You probably want to push it back. Can be.
It's visible like that. You can see everything.
Okay, so the question being asked is, how do you know this nitrogen is sextet? And the same, I also have, it's on my notes 3 back page. I also have another structure which has sextet, so we're going to find. So this is number 1, number 2, number 3, number 4, number 5, number 6. Okay, for this carbon, number 1, number 2, number 3, number 4, number 5, number 6.
It's more like, how do we know that it is an actual like sextet rather than like there's missing a lone pair?
So here, because both of these two was from a resonance structure that you draw already. When you before you draw this one, the charge came from you add if this charge was a assigned one, you either get rid of a charge from the previous atom or add one. Let's say the first one. Okay, what was the first one? Your first resonance structure, you start with, what's the oxygen, right? Okay. So the first one, you start with here, and then you draw the lone pair into that. You know your oxygen, your nitrogen lose something. The positive charge came from, you assign positive charge because, so this is not because you count the nitrogen. This is because your nitrogen lose bond. Okay, this positive charge, that's why I put description here in the front page. It's also just like, but on the front page, I said, okay, this chlorine, you have a change charge from 0 to positive 1 because a lone pair of chlorine was leaving and form a new bond. If I need to write the charge description here, it's because your nitrogen lose a bond, so you have a positive charge on nitrogen. If that's explained a little bit.
I get the positive charge. I'm just wondering, like, the other nitrogens and the other carbons in the rest of the examples all follow the octet rule. Why do these two in particular follow the sextet? Is it just because there's not enough electrons, and so you have to like?
Yeah. So, and that's also explain why this is minor, because it doesn't have the octet rule. If we don't have 8 electrons, your nitrogen just have to stay with that, which is a different scenario. But we just put them in minor because nitrogen is not happy overally in this case. Are we good with that?
Can you just list out like all the molecules that or atoms that use the sextet rule? Because I know you put it on carbon and nitrogen, but I'm not sure if you.
I haven't did this. I don't know. It's kind of like a case to case.
Okay.
Yeah, it's a. That's something I don't think you need a list of all rules. It's more or less, you come there, you count. I think it's easier to just count there 6 than you list all of them. It's more like a case to case. Are we good? Yeah. Okay, I might use sense, but this sense is more or less like it's like, I don't want people to memorize the resonance structure. I want you to form a sense of if this is quite right or quite wrong. If this is not something quite right to you, either it's a wrong structure or it might be a sextet.
Okay.
Are we good with that? Okay. So like from my view, this nitrogen is not quite right because it doesn't look something like on my chart, right? On my chart, if nitrogen is bound with 2 things, it's not supposed to be positive charge. That's why my sense starts to work. This is something wrong with it. Either so I trust my sense based on is this a wrong structure or is something that's not very usually common. If it's not common, it's minor. That's how I deal with this stuff. Yeah.
So just to make sure I'm clear on this, is the sextet always going to be minor when compared to a molecule that can fulfill an octet?
Yeah, let's say it's true for 118. Yes.
To add on to that, even if the sextet is like in an not essential atom, I guess, and in a
Yeah, so
it's
that's
fun.
that's the last example, right? That's yeah. Are we cool with that?
Can I just get an explanation on why that the bottom molecule is a minor one compared to the other one?
Okay, let me draw the other one. Do I? Okay. Okay. If you go to my notes 2 chart, if my carbon is bound to 3 things and with a pair of negative, my carbon should be 1 negative charge, right? Also, oxygen, if it's bound to 3 different things and it has a pair of lone pair, that's also one of the happy formats. It's on the chart, right?
Yes.
Okay. So when I view this, I'll tell you my perspective first. When I view this is not quite right because it's not on my sense table. This is quite right because all of the atom is in the format that they are happy with. So that's how I deal with. I use my sense, but my sense is based on that's really the chart table I was referring to. Okay. So now let's count. 1, 2, 3, 4, 5, 6, 7, 8. For carbon, it follows the octet rule. Am I good? Just raise this color.
Yes.
Okay, for oxygen, 1, 2, 3, 4, 5, 6, 7, 8. So both of them have fails the octet rules, right?
Oh, okay.
And the rule number 1 takes over rule number 2 and 3. Rule number 1 is you should have octet rules. So that's why in the Piazza question, it was being asked that it's really just in my perspective is I use a sense to see this is okay, this is okay. This carbon looks something wrong because it's not on the right thing.
I just wanted to explain my
Yeah.
reasoning.
Okay.
Is that I thought the other one was major because oxygen had the octet, but I didn't realize that carbon was supposed to also have it. And I understood, I took rule 2 that the negative charge was supposed to be on.
Yeah. That's why my explanation is rule 4, which rule 4 is rule 1 take over rule 2 and 3.
Thank you.
Okay. Yes.
Can you go over a textbook question?
Yes. But are we done with all this first? Are we done with all this? Okay, can people pause